Are we alone? No matter how much we gaze at the starry sky, the silence is deafening. In a universe filled with trillions of galaxies, it seems impossible that we are the only conscious beings. But what if we're thinking about it all wrong? What if life, so rare and precious, is vastly different from what we imagine? This video is not just about science. It's an invitation to dive into the deepest questions of existence, explore mysteries that defy our imagination, and perhaps discover our true place in the cosmos. Get ready for a journey that will change how you see the universe and yourself. The Earth is like a rare masterpiece in an almost infinite cosmic gallery. Think of tectonic plates, those gigantic gears of the Earth's crust, functioning like a natural thermostat. They not only recycle essential nutrients but also stabilize the climate, creating a hospitable environment for life. Imagine it as if Earth had an air conditioning system that never breaks down. Without these plates, we might not even be here to discuss this fascinating topic. The climate also deserves special attention. The carbon cycle, regulated by volcanoes and oceans, acts like a conductor, ensuring balanced temperatures for billions of years. A practical example? Venus and Mars. Venus fell victim to a runaway greenhouse effect, while Mars, lacking tectonic plates, lost its atmosphere. The result? One is a cosmic oven, the other, a dry freezer. Earth hit the Goldilocks zone, just right. Not too hot, not too cold. Moreover, the moon plays a critical role. Yes, that bright satellite inspiring poetry is also a stabilizer of Earth's axial tilt. This constant tilt keeps the seasons predictable, creating favorable conditions for biodiversity to thrive. Without the moon, Earth would be a chaotic mess, with extreme climate shifts. It's as if the moon is our silent partner in the dance of life. Now consider this. Is the combination of factors we have here so rare that it makes life a privilege exclusive to Earth? This question leads us to reflect on the deafening silence of the cosmos. After all, if there are so many planets out there, why haven't we heard from them yet? Let's delve into this intriguing doubt. The Fermi paradox is one of those questions that boggles anyone's mind. If the universe is so vast and full of potentially habitable planets, why haven't we heard anything from our neighbors? It's like being at a giant party, with loud music and flashing lights, but finding no one to talk to. Are we looking in the wrong places, or does no one want to be found? One of the most unsettling explanations is the dark forest hypothesis. Imagine the universe as a dense, dangerous forest where every civilization hides to avoid being attacked. In this scenario, revealing your position would be like shouting in a hunting ground, a beacon for predators. This might explain why we don't see any signs. Advanced civilizations might prefer strategic silence. On the other hand, we could be either too early or too late in the cosmic timeline. Perhaps other civilizations rose and fell before our telescopes even existed. Or maybe they're still forming, like seeds waiting for the right moment to sprout. Time is a crucial player in this universal game of hide and seek, and there's always the chance the solution is simpler. Perhaps we're not looking in the right way. Our radio signals might be ineffective or insignificant to those living thousands of light years away. What if, while we focus on technology, the true answer lies in the simplest forms of life? This last possibility brings us back to the microscope, as we'll explore next. Microbial life is the undisputed veteran of Earth's history. For more than 4 billion years, bacteria dominated the planet, enduring conditions that would make most other life forms give up. These tiny survivors lived everywhere, from boiling hydrothermal vents to the icy edges of polar caps. This leads to an intriguing idea. If life exists beyond Earth, it's likely to be microscopic. What makes microbes so incredible is their adaptability. At the bottom of oceans, near hydrothermal vents, bacteria transform heat and sulfur into energy, a biochemical system entirely independent of sunlight. Now, imagine, what if on moons like Europa or Enceladus, where oceans are hidden beneath layers of ice, this same type of life is thriving? These bacteria could be the universal standard for life. Moreover, understanding microbial persistence teaches us about the limits of habitability. Bacteria survive radiation, the vacuum of space, and even crushing pressure. In many ways, they are what we could call hardcore life, not dependent on ideal conditions to thrive. This redefines how we interpret the idea of habitability and where we search for biosignatures beyond Earth. Looking at these microscopic creatures, one question stands out. Are we underestimating their role in astrobiological exploration? Advances in technologies like the James Webb Telescope can help identify these subtle but decisive chemical signatures. And this is where science becomes even more fascinating. As we turn to exoplanets, the search for life on exoplanets is like finding a needle in a haystack, but with increasingly sharp tools. Since the discovery of the first exoplanets, science has leaped forward. Today, we have the James Webb Telescope, which not only observes distant planets but also analyzes their atmospheres for unmistakable chemical signs of life, so-called biosignatures. Imagine detecting methane, oxygen, or even phosphine in anomalous proportions. It would be like finding a note signed by aliens. These advances focus on super-Earths, planets slightly larger than ours, with characteristics that might be ideal for hosting life. Think of a world where conditions are even more favorable than Earth's. More resources, stable climates, and, perhaps, unique life forms. But how can we be sure these planets truly harbor life? The answer lies in spectroscopy, a technology that reads the light from exoplanets like a chemical book. Another fascinating method is transit detection, which observes tiny drops in starlight as planets pass in front of their stars. It may sound technical and distant, but it's not much different from using sunglasses to see better under intense light. This technique has already revealed worlds of lava, oceans, and even dense atmospheres with potential for unimaginable life forms. With so many possibilities, the question is not just where to look, but how to interpret what we find. After all, life could emerge in unexpected places and under extreme conditions. And what if the pace of life on other planets is determined more by the time of their stars than by immediate conditions? This leads us to the next point: stellar evolution and its impact on habitability. Stars are the clocks of the universe, dictating the rhythm of life on the planets orbiting them. Our Sun, for example, is halfway through its life cycle, offering enough stability for Earth to remain habitable for billions of years. Now think, if the Sun were much smaller, like a red dwarf, or much larger, like a blue giant, the scenario would be entirely different. Small stars can live for trillions of years, while larger stars burn quickly and die young, like cosmic fireworks. This stellar evolution is crucial for determining habitable zones, the Goldilocks regions where the temperature is just right for liquid water. But even within these zones, variations in stellar brightness can wreak havoc on climate. Imagine a planet like Earth but orbiting a star with constant solar flares. It would be like trying to live in a place where hurricanes strike every single day. The Sun's stability is one of the key reasons complex life has thrived here. Interestingly, smaller stars, like red dwarfs, might actually be better candidates for life. They live for extraordinarily long periods, providing more time for life to evolve. However, their habitable planets are so close that they become tidally locked, with one side perpetually facing the star and the other plunged into eternal darkness. This creates a fascinating challenge. Perhaps life on these worlds thrives in the twilight zone, the narrow band between day and night. The idea that stars shape life forces us to reflect on our place in the cosmos. Does life on other planets require the same stable dance between star and planet that we have here? This question brings us closer to home, to the moons of our own solar system, where new clues about life might be waiting. Within our solar system, the moons of Jupiter and Saturn steal the spotlight when it comes to the search for life. Europa and Enceladus, for instance, hide vast oceans beneath their icy surfaces. Imagine hundreds of kilometers of water, more than all the oceans on Earth combined, protected by a thick layer of ice that shields them from radiation. Under these conditions, hydrothermal vents at the ocean floors could sustain bacterial communities, just like those in Earth's deep-sea trenches. Enceladus, Saturn's small moon, has already shown intriguing signs. Plumes of water rich in organic compounds have been observed shooting from its interior. It's almost as if the moon is breathing, releasing molecules into space that can be analyzed by probes like Cassini. It's as though Enceladus is inviting us to investigate. If life exists there, even in microbial form, it would revolutionize astrobiology. Meanwhile, Europa, with its surface crisscrossed by icy fractures, could host an ecosystem as complex as Earth's deep ocean trenches. Studies suggest that gravitational interactions with Jupiter and other moons generate enough heat to keep its subsurface ocean liquid. What if, in this vast underwater world, chemosynthetic creatures are already thriving? This possibility reminds us that life can emerge in conditions we never imagined. But the potential for life isn't limited to icy moons. Mars, with its signs of underground water and organic molecules, remains a strong candidate. Even Venus, with its clouds containing traces of phosphine, challenges our assumptions about habitability. These explorations open new frontiers, but also raise a fundamental question. Why, with so many possibilities, haven't we found clear signs of life yet? This brings us back to the haunting implications of the Fermi paradox. The Fermi paradox casts a shadow of mystery over all our searches. If so many conditions seem perfect for life in the universe, why is the silence so deafening? This paradox isn't just a scientific question. It challenges our most basic assumptions about the cosmos and even ourselves. Maybe we're simply asking the wrong questions or using the wrong methods. One provocative explanation is that we are the first. Imagine the universe's history as a book, and we're reading the first few pages of a story that will unfold over billions of chapters. Perhaps other civilizations are still in their infancy while we are pioneers, transmitting signals and exploring exoplanets. In this case, the cosmic silence isn't rejection, it's the beginning of a long wait. Another hypothesis suggests that advanced civilizations avoid contact. The idea that the universe operates like a dark forest, where each civilization hides to avoid extinction, paints a more hostile picture than we might like to imagine. This could explain the silence, but also forces us to reconsider what it means to search for life safely and ethically. Are we willing to expose ourselves in a galaxy that might be dangerous? Despite its unsettling implications, the Fermi paradox should not discourage exploration. Instead, it pushes us to think more deeply, use more advanced technologies, and broaden our definitions of what constitutes life. The silence may be temporary, or it may be the cosmos's greatest lesson, that life, even when possible, is an extraordinarily rare treasure that must be cherished. As we continue to explore this paradox, new questions arise, motivating us to keep looking at the sky with curiosity and hope. Now that you've explored the mysteries of the universe and understood how life on Earth is a cosmic rarity, pause and reflect. What will you do with this knowledge? Are we truly alone? And if we're not, are we capable of understanding and valuing that connection? Think about everything science has revealed so far. Each discovery brings us closer to answers that could reshape humanity's future. But what about you? Which theory intrigues you the most? Do you believe in the possibility of life out there? Or is the silence of the universe proof that we are unique? Share your thoughts in the comments. Your perspective might open new horizons for this debate. And don't forget, subscribe to the channel, turn on notifications, and share this content with your curious friends. Together, we can keep unraveling the secrets of the cosmos. Who knows, the next great mystery to be solved might come from an idea of yours.